digitCount. Let's solve digitCount. We write a function that takes a possibly negative int and returns the number of digits in it. Pretty straightforward. So the digitCount of 1, 2, 3, 2, 3 returns 1, 2, 3, 4, 5. DigitCount of 0 returns 1. There's one digit. We don't count leading zeros in general, but for the number 0 itself, we have to count that digit. Negative numbers are the same as positive, so negative 111 still has 3 digits. We could certainly just turn the number into a string, taking the absolute value to get rid of the negative sign, and just take the length of that string. That works, but it's not allowed because we aren't using strings this week. And in general, you should resist the urge to solve numeric problems using strings. You could actually solve it also using logarithms. If you knew what you're doing, mathematically you'd know that that the logarithm of a number is closely related to the number of digits in that number. But as this says, it's loops week, so we're not going to do that. We're going to simply loop, plucking off the ones digit over and over again until we cannot do that any further. Fine, let's go for it. Here is digitCount. We have a number n. I should say I'm going to deliberately put a couple errors in here that we'll get out in a moment. But to begin with, we said we're going to pull off the ones digit. Well, the ones digit is n mod 10, right? And it turns out we actually can ignore the ones digit. We don't care what it is. We just want to keep going so long as there is a ones digit. So long as there is a ones digit, which means n is greater than 0, right? That means there's a ones digit. We will increase the count. We're counting the ones digit as we go. So we need a count that starts out at 0, and then as long as we have a ones digit, we'll increase the count, and then we'll get rid of that ones digit. For that, we'll divide n by 10. So if n was, say, 342, after this, it should be 34. Okay? And then when we're done, we'll go ahead and return our count, which should be the number of digits. Hopefully you see a couple mistakes in this code. And when I go ahead and I run this, sure enough, it did not pass. And the digitCount of 3 we thought should be 1, and instead we came up with 325. So this code thinks there are 325 digits in the number 3. There's something naturally very wrong with this, right? So let's go ahead and do a manual trace. Okay, so let's just say that n equaled 3. There's n, okay? And here's our count at 0. So you can actually even do this yourself. Count is 0. So now, is n greater than 0? Well, is n greater than 0? You bet it is. So we get inside here and add 1 to our count. So count plus equals 1. Our count is now 1. N divide equals 10, because we're on this line. We sure would hope that this is going to produce n of 0. What's n, just for kicks? 0.3. 0.3. We just turned our int into a float. And now we see the problem. 0.3, 0.03, 0.003, and so on. We didn't mean for there to be floats. We wanted this right here to be integer division. Okay? Much better, not right still. Because now, look. First off, if we look at our test cases, we would see, go down here to your test cases. We got through this test case and that case. So we got through a bunch of test cases. We're doing pretty well, but we failed on this test case. Negative 3030. And what we realize is by hand tracing it, n is negative 3030, count is 0. Negative 3030 is not greater than 0. We fail immediately, and we return 0. This is one of those cases where being negative does not affect the logic of the problem. And so we have learned the technique of simply taking an absolute value to deal with that. And indeed, we got past that test case. But we are stuck on yet another test case because we're not working right exactly when n is 0. Because what's going on here is, well, n is 0, count is 0, 0 is not greater than 0, return 0. We could try to play around with this in here and adjust our logic for the case when n is 0. But frankly, n is 0 is a special case. And while you cannot hard code general cases, that would be wrong. And you cannot hard code cases that the autograder finds incorrect that aren't obvious special cases. You can hard code 0, you can hard code 1, you can hard code -1. In this case, we're going to hard code right off the top that if n is 0, simply return 1. Now, if we get past there, we know that n is non-zero. And we work in all the non-zero cases. So in fact, now we simply work. And there is a candidate solution to digit count.